Hello there, my name is Peyton. I heard you're looking for some help with domains and ranges. Let me see if I can lend you a hand. First, let's review what a domain and range are for a function. A domain for a function is the intervals or sets of x values that a function is defined on, or for that function to make sense to be defined on. The range of a function is the intervals or sets of y values that the function is a result of. Okay? And just to get an idea, let's look at an example. We want to look at what the domain and range are of the following. And here's a graph. We're told that this is a line and it extends without bounds. So first, let's start with the domain. So what are the possible values, the x values that we can have? Is it an interval? Is it a set? Is it something like that? And since we are told that the line extends without bounds, I would say that the domain would be all real values, or x such that x lives between negative infinity or positive infinity. Okay? And that's because it extends without bounds. Second, the range. And we're going to follow the same idea because the line extends without bounds. And it would be all real values, or y such that y exists between negative infinity and positive infinity. Okay? That's our first example. Now, let's move to another really big concept. And that would be a discrete function or a continuous function. And let's look at the definitions of these. A continuous function is exactly as it's described. It's continuous. We can draw the line without picking up our pencils. There's no gaps. There's no spaces or anything. It's a continuous line. A discrete function is where information is determined by sets of points. It's not continuous. We can't really draw it without picking up our pencil. We have to sit there and dot it usually. Okay? And here's a graph of the discrete function. Notice on the information it's dots, it's points, it's just randomly put on there. It's possible to put a function to this graph, however, it's unlikely that we can. Okay? Now, let's look at the domain and range of a function for the number of cars sold by a car dealership in a week. We're told that the dealership can sell no more than 15 cars a day. All right? So, I'm going to claim that the domain is the set 1, 2, 3, 4, 5, 6, and 7, because there are 7 days in a week. So our x values will be day 1, day 2, day 3, day 4, day 5, day 6, and day 7. Okay? And it makes sense that it's integer values because we don't want to really look at what happens at day 3.5. Okay? We don't really care. We only care about day 3, and that's from the beginning of day 3 to the end of day 3. All right? Now let's look at the range of the function. I say that it's the set 0, 1, 2, 3, 4, 5, up to 15. And we can say it's up to 15 because the car dealership can sell up to 15 cars a day. We start at 0 because they could possibly sell no cars during the day. And they're all integers because it doesn't make sense to sell half a car. I mean, could you imagine driving home in half a car? All right? It also doesn't make sense that negative values are included because you can't have a negative car. Okay? Let's look at a possible table for the amount of cars sold in a day by the dealership to see how we can see that this function is a discrete function. And here's the table here. We have our days as our x values and the number of cars sold as our y values, and we're told on day 1 they sell 4 cars. On day 2, 7 cars. Day 3, 3 cars. Day 4, 13 cars. Day 5, no luck, they didn't sell any. It was a bad day for somebody. Day 6, 9 cars. Day 7, 4 cars. And I don't understand why on day 7 they're selling 4 cars, but that's up to them. Now, looking at the table, we can notice there really isn't much of a pattern to the information. It doesn't look like we can put a function to it. And so it's a pretty good indication that it's a discrete function. It's not necessarily continuous. Okay? It's not a set-in-stone thing, but it's a pretty good indicator. Okay? So, let's look at some more examples. For the following statement, classify the function as discrete or continuous, then state the domain and range. A flock of geese is traveling south for the winter. On a particular day, they can travel an average of 42 miles an hour. Okay? And they travel for a maximum of 14 hours during the day. Distance is a function of time traveled by the geese. Okay? So, what is the domain and range of the function, and is it discrete or continuous? First, let's determine if the function is discrete or continuous. And let's take an educated guess. I would say it's continuous. All right? Now, let's look at the domain and range to see how we can figure out why that is. First, let's look at the domain. And I would say it's the interval from 0 to 14. And it's time. Remember, time is our x value. So we go from time 0 to time 14. And it's an interval. We include all points within the middle because you can look at the time travel or the distance traveled at time 3.5. We can look at the distance traveled at 7.9 hours. We can look at that interval. We can look at that time. And then for the range, the minimum distance that the geese can travel in that day would be 0 miles. The geese just woke up and went, I don't want to fly. Just don't feel like it. And then the maximum distance they could travel would be 588 miles. And that comes from they can travel a maximum of 14 hours at an average speed of 42 miles an hour. Okay? So the range would be the interval from 0 to 588 miles. Okay? Now the function is continuous because the distance traveled at any time between 0 and 14 hours, we can determine any of those distances. Okay? We can find that the distance traveled at 3.68 hours. We can find that distance traveled. If we felt up to it, we could find out how much time it took for the geese to travel 500 miles or 300 miles. It's a continuous distance. We can also tell that the function is continuous by looking at both the domain and range because they're continuous intervals. They're not sets of intervals, they're not sets of points. Okay? Now, let's look at a table of values, and here's a table. We're going to only worry about up to 6 hours, and so we have time as our x value and distance traveled as our y value. And we see that at time 0, the geese haven't traveled any distance, and it makes sense. They woke up, they're looking at the sky going, I don't really want to fly yet. And then we can go through and we can see it after 1 hour they travel 42 miles, after 2 hours 84 miles, and so on and so forth. We see at 6 hours they travel 252 miles. Now, looking at the gradual increase of the distance, we can see that it's a continuous, steady increase. Okay? And it's a pretty good indication that it's a continuous function. Now, let's look at a graph to get another idea. All right? And here's the graph plotted. I've rearranged the intervals so we can see the necessary information. Our x values are from 0 to 14 because that's the maximum time we can travel, and the y interval is from 0 to, I think, about 600. But we can see that the graph is linear, and that's because they travel at that average speed of 42 miles an hour. And we notice that it's continuous. There are no gaps. I can pick up my pencil here, and I can draw this graph without picking up my pencil at all. It's continuous. Okay? And it makes sense that it's continuous because the geese can't magically be here at time 0 and then reappear 500 miles away at time 0.1. It doesn't really make sense that there's a gap in between the two of those. Now let's look at another example. We're told that the number of students in a class is a function of time. We're asked to classify if the function is continuous or discrete. Okay, we can determine the classification of our function by looking at the domain and range. And here I say we should look at the range first because we can only have whole students. We can't have half students. I don't want to think about what that looks like. Don't ask me. And by doing so, we have whole numbers. We have integers. So I say the range would be discrete. Now, let's consider the domain. We can have a continuous domain. The time can be continuous, but it's unnecessary because the number of students changes at certain times. Okay, so it's going to be graphed by points, not by a line. Okay? And since that is the case, the domain will be discrete, and therefore the function is discrete. Now let's look at a possible table of values where the x value is the time in hours, and the y values are the number of students. And so here's just a quick little table. We say we start at time 0, and there are 24 students in the class at that time. After an hour, a student joins the class. After 2 hours, 4 students leave. After 3 hours, 2 more students join. 4 hours, 3 students leave. 5 hours, 5 more students leave. 6 hours, it's resets. Everybody's gone. They just want to leave. Okay? And we can look at the correlation of time and the number of students and see there's not really much of a correlation. There's not a function we can make. There's not a way that we can say, okay, at this time we will have these students. You can't make a function to look like this. Now let's look at a graph. Okay, and looking at this graph that's right here, we see it kind of does this weird little hump thing. Okay, and we notice that the information is plotted by points, not by a curve, not by a line. Okay, this is solid. solid evidence that the function is a discrete function. Okay? Now, let's look at one more example, and bear with me on this example, it's a little tedious. And we're going to look and see how to determine its range, its domain, and classify if it's a continuous or discrete function. And this is an engineering concept. When building buildings, towers, bridges, things of that nature, engineers use trusses or beams, and they're always arranged in a triangular pattern. And so we're going to start with just the basic triangle here. And it's just an isosceles triangle. We're not going to worry about it. When engineers add additional beams, they can only add 2 at a time. And over here, here's an example of that. We have our normal triangle, and then we've added 2 more lines, 2 more beams, okay? And let's add another set of beams. So here's what that would look like right here. Now let's try to model the perimeter of the figures as we add beams. And we're going to assume that the length of each beam is 1. And here's a table of values. The x value will be the figure number, and the first figure is just our first triangle. Okay, and here's our table. Figure 1, the perimeter is 3, because we have 3 sides to our triangle, and 3 times 1 is 3. On our second figure, we add 2 beams, but our perimeter is 4. On our third figure, we add 2 more beams, and our perimeter is 5. Now, let's try to develop a function for this information by using the slope of a line and the slope-intercept form of an equation. And I say that this information can be modeled by the equation y equals x plus 2. The perimeter of a figure is equal to the figure number plus 2. All right? Now, let's play with this a bit to determine the perimeter of a figure, say, figure 14. And we have to simply input 14 into our equation, substituting it for x. So y equals 14 plus 2. Therefore, y equals 16. So the perimeter for figure 14 is 16 units. Now, let's determine the domain and range of a function. I say that the domain is 1, 2, 3, 4, 5, 6, so on and so forth, but they're only integers. And the range would be 3, 4, 5, 6, 7, 8, up to x plus 2. And we start at 3 because with figure 1 we have a perimeter of 3. Now, looking at the way the domain and range are defined, we can easily state that both are discrete, and therefore the function is discrete. Pretty easy, huh? Before you go, let's take a look as to whether a function is continuous or discrete and the domain and ranges. If a function is continuous, then both the domain and the range are continuous. If a function is discrete, then both the domain and range are discrete. So if we can determine if a domain or the range is discrete or continuous, then the function follows that pattern. Okay? This is a pretty cool shortcut. This is what you should look for. Always try to get something with a domain and range, and you can easily classify a function. That's all I have for you. I'll catch you next time.